there's water involved. What happens is this. Ammonia needs that water. And so we're going to have ammonia and water. Ammonia needs that water because we have hydrolysis. And the ammonia and the water hydrolyzing is going to form ammonium and hydroxide. All right, so eventually we're going to hit this point where the formation, did I already talk about this? The formation of ammonium hydroxide, the balls rolling up is equal to the balls rolling down. So that we have this is equilibrium. Equilibrium. That is, the forward reaction is equal to the reverse reaction. The water is going to be involved because of this. As the magnesium comes to react with the hydroxide, you think, well, it's only 1.3% reaction, so that's not much hydroxide. If we don't have much hydroxide, we're not going to form much precipitate, are we? But we have to remember Le Chatelet's principle. What does Le Chatelet's principle say? Le Chatelet's principle. What chapter was Le Chatelet's principle? Oh yeah, Le Chatelet's principle is chapter 18. What does Le Chatelet's principle say? Well, you have a couple of choices. You could memorize this outright. If an equilibrium system is subjected to change, processes tend to partially counteract the initial change if an equilibrium system is subjected to change. Brings the system to a new position of equilibrium. You know, that didn't make any sense to me, so I skipped this slide completely. You remember I skipped this slide and just went to the example. When we talked about the example here, we talked about what happens here to the balance. You know, I don't know if this favors the product or favors the reactant, so we don't know what the balance is, but let's say there's some kind of balance here. And what happens if you add more H2S to this, or increase the H2S concentration? Well, if you increase the H2S, it upsets that balance. And the balance is this ratio that we're supposed to have at equilibrium. And if that ratio gets upset, is that stable? No, it's not stable. So what's going to happen is the ratio has to be reestablished. So that means if I increase the H2S, I'm going to expect a forward shift or reverse shift to correct the ratio. Forward shift. And so you want to explain Le Chatelet's principle in your own words. How would you explain it? Well, think about that. And so what we have here happen is we have this ratio like this. And I'm going to be eating up the hydroxide because the magnesiums are going to be removing the hydroxide. As magnesiums remove the hydroxide, what happens to this ratio? The ratio should be 1.8 times 10 minus 5. If I start consuming some of the hydroxide, then the amount of product is going down, which means it's getting even smaller. And so that's going to upset the balance. So what Le Chatelet says is this: as the magnesiums react with the hydroxide is being removed from the equilibrium. As the hydroxide is being removed, this is going to shift right or shift left. It's going to shift. It's actually going to shift right. And so there's another way of visualizing this ratio. The other way of visualizing it is imagine that we have a tub. And the tub is shaped like this. We'll call this the reactants, we'll call this the product. Which side is favored? The reactant side or the product side? If I were to fill this up with water, if I were to fill this up with water, I'd get a lot more water here than here. And so if this is at equilibrium, what I'll see is that the two water levels are equal. That is, the rate of the forward is equal to the rate of the reverse. In other words, water is moving back and forth freely, but there's no net change. We don't have net forward, we don't have net reverse. There's no net change. And so the two water levels are equal. Although the two water levels are equal, clearly one side's favored. Which side is favored? Reactant side. We need this ratio. The ratio is for every one product, for every one reactant, I need 1.8 times 10 minus 5 product. And so that's the ratio. If I remove hydroxide, hydroxide is a product. And so this is like removing water. If I remove water from here, which way is it going to shift? If I remove water from here, then I'm going to get net shift forward, because this side has to go up, this side has to go down to establish or reestablish the correct ratio. So this side's going to go up, this side's going to go down, and eventually I'm going to hit a new equilibrium here in which I maintain the correct ratio. But right now the ratio is not correct. I don't have enough product. Does that make sense? And so if I start removing hydroxide here, interestingly enough, what's going to happen is more hydroxide is going to form. As more hydroxide forms, and more magnesium can precipitate. So even though it doesn't sound like there's much hydroxide, more can be made. And so this is the role of water. Water's around, there's plenty of water around, so just keep reacting the magnesium 2+ with water to form more hydroxide. But we don't care about this, we care about the overall. What's the overall reaction? Can someone get the overall reaction? No? All right, we're going to go on a break. So let's take a break, and then we'll continue this after the break.